Okay, we're going to look at probability and specifically how to solve probability questions with tree diagrams. So the first question is, what is the probability that a family with 3 children has at least 2 boys? Okay, so since this is a word problem, we're going to read it twice. I'm going to highlight important pieces of information here. So what is the probability that a family with 3 children, okay, so this family has 3 children, has at least 2 boys? And the word at least is actually really important in this question. Okay? What it means, think of it as like a greater or less than sign. In this case, it's actually a greater than sign. So greater than and at least and equal to. So it means greater than and equal to the value of 2. So what does that mean in terms of a family of 3? Well, that means the family can have at least 2 boys. So that means they can have a boy, and then a girl, or they can have a boy, and a boy. So it's actually almost 2 major family dynamics that are different here. It doesn't matter the order in this question. They didn't specify the order. All we need is that they have at least 2 boys. So a family with 2 boys and a girl, or 3 boys. How do we go about solving this? We can use a tree diagram to help us figure out the probability to a question like this. So when we're having children here, we have the option, we have one of 2 options. You will have a boy, or a girl. So we'll call that first kid. Okay. What about your second kid? Well, after you have that, you will then from the boy can have a boy or a girl, or again, a boy or a girl. Okay. So in this case, if you take this root, that's going to be boy. I'm going to choose the letter B to represent boy and G to represent girl. So you can have boy, boy. Or you can have boy, girl. Or in this case, you can have girl, boy. Or you can have girl, girl. And finally, I'm going to have to move this around. I have a lot of room here. Let's move this whole thing down. There we go. These, second kid, first kid, perfect. Finally, our third kid. Well, again, each kid, we have an option of either a boy or a girl. So same concept. We could have, in the third child, you could have boy, boy, boy. You could have boy, boy, girl. You could have boy, girl, boy. You could have boy, girl, girl. You can have girl, boy, boy. You can have girl, boy, girl. And you can have girl, girl, boy. Or you can have 3 girls. Okay? So, just to help us out on figuring how this was made, maybe this tree diagram wasn't the easiest to follow. Every arrow pointing upwards was representing a boy for us. So that's having a boy, having a boy, having a boy. Okay? Any arrow or line heading downwards represented having a girl. So having a girl, having a girl, having a girl. So visually, we can help figure out this root by actually coloring in our line. So if any line that's going down, I'm going to color this reddish, maroonish, purplish color. I'm not quite sure. That's going to be girl. And any line that is sloped upwards, it's going to represent a boy. So let's try to follow this path, okay, that we made. Okay, so this would be having boy, boy, boy. Same root, but then a girl. And as you can see, we've listed them out with letters. And this gives us every possible option. Well, how many are there? We have 1, 2, 3, 5, 6, 7, 8. Great. And there are 8. Because there's always 2 options, think of it like 2 to the power of 1, 2 to the power of 2, 2 to the power of 3 would represent the number of trials or possibilities. So we know that there is a probability of something in 8. Okay? How many of these have at least 2 boys? I'm going to use the yellow highlighter to highlight at least 2 boys. So 3 boys, that's one of the options. Another option, 2 boys here. We also have 2 boys in our third option. Here we only have one boy, so this doesn't count. We have 2 boys in that option, and then 1 boy, and no boys. So look at this. You have 1, 2, 3, 4. 4 of the options, or 4 of the possibilities out of the 8 total, okay, are at least 2 boys. So half of your possibilities are at least 2 boys in this case. You could have done the same thing with girls. If we said at least 2 girls, it would have been the other options, 1, 2, 3, and 4. Another way we could have added this together is we could have separated families of 2 boys and 3 boys and then added those probabilities together. So how would I have done that? Well, I would have counted the total number of outcomes that had 3 boys. Well, there's only this one here. So there's a 1, and remember there's 8 different trials, a 1 in 8 chance. And here we have 1, 2, 3 families that have 2 boys, so there's a 3 in 8 chance. If we had added those 2 fractions together, we would have gotten, this would be our equal sign here, 4 out of 8. So 4 out of 8 possibilities. Just the same way we just counted and put them over 8. So the number of successes, in this case, boys, sorry, I should say equal to and greater than 2 boys, that's an S, not a Z, over number of outcomes or trials. And that's how we calculate the probability using a tree diagram. Okay?